Here we go. Page 148, you're gonna have this little half sheet right here. This is the only one, little half sheet this time. It's gonna go on page 148. Okay, and then you are gonna look at it. You're gonna decide which of those four sequences does not belong. Which one of those does not belong?
Oh, page 148, yeah, that's what I'm on.
Totally have my page.
Yeah.
You're gonna wish you did whenever you have your notebook check next week.
What?
What?
Well, time started blowing in. Oh, yeah. First step in general. Sorry, I don't have yeah. That one. Five. All right, serious. We got E. Yeah, E.
All right, talk with your neighbor about which one you said did not belong.
You're going to see, I don't think it's very logical.
Oh,
I would go for something like, where it's going to seem people we don't know it's right.
Well, actually, I would say let's stick with C. Right off the bat, we're finding what the function of one.
See, I don't have any of the zero in school.
Did anybody say that A doesn't belong?
No, it's actually right. So,
No one?
So what does in mean? Because I was like watching the videos for the bond and I don't know.
N is the step number. Okay, so this one is talking about the first step.
Okay.
It's always going to give you the first step. And then N is any number after that.
Okay.
Okay, so what's happening between each term in this sequence? Yeah, they're subtracting 5. Okay, so for this sequence, we would start at 6, and each one we would subtract 5. So minus 5 is 1, minus 5 is -4, minus 5 is -9, dot, dot, dot. Should keep going. Okay, what's happening on part B? Did anybody say that one doesn't belong? Really? It's the only one with a fraction.
Yeah.
that's pretty
So
high.
when you multiply by half.
Means you're multiplying by half each time. So we're going to start with 6 times a half is 6 times times a half is, 4 times a half is, thank you. Okay, what about part C? Does anybody say that that one doesn't belong?
I did.
Why?
Because it is the function of 0, all the rest of them are the function of 1.
Yes, so this one starts at 0.
Yeah, we don't like that.
You don't like that?
No,
No,
yeah,
I'm not gonna take it.
No, it's dumb.
There's not, it's yeah.
It can start at 0, this just means you start at step 0 instead of step 1, which is fine. Okay, what's happening between each one of these? Multiply by 10, so we start at 6, and then 60, and then 600, and then 6,000. Forever and ever.
Wow.
Okay.
You said E, that's not up there. You should have.
Okay, what about sequence D? Did anybody say that one doesn't belong? Why?
I've never seen it squared before.
Yeah, for
Never
real.
seen N squared?
Well, like, I did like once in the video. Does it?
Okay, I would agree with that. Okay, so it starts at 6, and then let's see what this actually says. So you take the term before it and then subtract N squared. Well, if that was step 1, this would be step 2, so this would be 6 minus 2 squared. What's 2 squared? 4, and 6 minus 4 is 2. Okay, so for the next step, my answer would be 2 minus, that's step 1, 2, 3. 3 squared is 9. 2 minus 9 is negative 7. Okay, then for the next one, we have negative 7 minus, that's step 1, 2, 3, 4. 4 squared is 16. Negative 7 minus 16 is negative 23. I don't like this one. Okay, so do you still agree with your answer that you had said before? Barrett's really the only one that committed to one of them.
Yeah, that's it from me.
No, I didn't think to be. I don't like it.
Part D.
Yeah, he's dumb.
Okay. What kind of sequence is sequence A? Is it arithmetic, geometric, or neither?
Geometric.
Arithmetic, because it's subtracting 5, right? What about B? Geometric. C? Geometric. D? Neither, right? So A could be weird because it's arithmetic, it's the only one. C, or D is the only one that's neither. Okay? The truth of the matter is they all don't belong for different reasons.
Yeah.
Really?
Really.
Oh my god.
There was not a wrong answer.
It doesn't.
There was not a wrong answer
Specify enough. It's like which doesn't belong. That's kind of objective.
Yes, exactly, that's the point. The conversation started.
Alright, cool.
Which doesn't belong. F1 equals 6.
Okay, but you guys all found all the things that were important here, so that's good. Okay? So now we're gonna have a card activity.
Let's go.
I didn't want to show that. Okay, who wants to be my partner? I'll give you the easy card.
Like if we're your partner, we don't have to do anything?
Yeah.
Oh,
You? All right. Barrett, you get to be my partner. Okay, so I have 2 cards here. One of them is a problem card and one of them is a data card. Okay, I'm gonna keep the problem card because I think that one's the more difficult one for now. And he's gonna get the data card, okay? So my problem card says, represent the first 5 terms of the sequence F by creating a table and sketching a graph. Okay, that's all the information I have. First 5 terms by creating a table and sketching a graph. Okay, Barrett has all the information that I need. So I'm gonna tell Barrett, hey, I need to create this sequence. I need a flip slide.
Info.
Okay,
I didn't understand that.
that's okay. All right, so Barrett, if I'm going to create sequence F, I need to know where it starts. So Barrett, where does sequence F start?
At 16, I think,
How do you know?
because it says it right there.
It says F of 1 equals 16?
Yeah.
Okay, so it's going to start at 16. So 16 is the first term of my sequence. Okay, what else should I probably know? Not Barrett. Somebody else knows. What else should I probably know? The step number?
You're gonna be moving on down.
I'm gonna move on down the sequence, right? So how do I get from one term to the next, Barrett?
Okay, stay with me here.
Okay,
So, it looks like, is that a slope? It's a graph, right? Sort of.
Maybe multiply.
they gave you a graph?
I think, no. I think I've got a slope right here. It looks like a fraction,
Really?
right? Okay. So f, and then you begin parentheses, n minus 1, and you end the parentheses. Then put that over 2. Okay?
So it's 1/2 times f of n minus 1.
No.
Pi?
Okay.
Is that the last part?
Okay. F,
I got that word.
then you begin the parentheses, n minus 1. Yeah, okay, minus 1. Okay,
Like that?
yes, over 2.
Okay.
I think Barry's making this one.
Okay, you got that. Now, something else you should know is that n is greater than or possibly equal to 2. Possibly. Let's not shut that out as an option. It's still an option. Okay, now that's all I got.
That's all you got.
I refuse.
Okay, so what does this mean?
I multiply by
That is an excellent question.
Okay, you take the term before it and you divide it by 2, or you can multiply it by 1/2, right? So if my first term is 16, how do I get the next one?
multiply by
Multiply by 1/2, and what is it? 8. How do I get the next term? Divide by 2 and you get, divide by 2 and you get, right? Okay, but my sequence, or my problem card says, represent the first 5 terms of the sequence by creating a table and sketching a graph. Okay, so I'm gonna have my table n and f of n. And I'm gonna have step 1, 2, 3, 4, and 5. And so that was 16, 8, 4, 2, and 1. So there's my table. Do you agree with me?
Mm-hmm.
No.
Yeah, it looks pretty cool.
Okay, now I also have to make a graph. Am I gonna connect the dots on my graph? Why not?
Because, I don't know, I just seen a lot of stuff connected.
Am I gonna have a step 1.5 or step 2.5? 2, 4, 6, 8, and 12, 14. Alright, so step 1 was 16, step 2 was 8, 3 was 4, 2, and 1. Right. What's geometric?
Mm-hmm.
I agree. Okay, so I have completed what they asked me to do. I found the first 5 terms, I created a table, and I sketched a graph. Thank you, Barrett, for giving me all of the information that I need.
You're welcome.
Okay, that's how this card activity is gonna work. You and a partner, only groups of 2, are going to get cards. Okay, one of you is gonna get the data card, the other person is gonna get the problem card. So one of you will be writing, the other person will be giving the information. Okay, just like what happened here. Does that make sense? All right. There's a lot of words there that don't really matter. Okay, that's the one we just did. And here are the correct answers. So what do you know? We did it correctly. Good job, Barrett. Thank you for all of your help. All right. So now I'm going to give you and a partner. So everybody stand up and find a partner. Give them an elbow bump, not a high five, just COVID.
I mean, I've already done it.
Barrett, on
Do I have to find a partner? I already. If there's an odd number, I'll just, yeah.
15, yes, there is not a number, so you get to just pay. Okay, everybody needs a partner.
Where's their process?
You got that. Oh.
I just survived that for 2 years.
All right. You problem
My job, except to look at and put it. Oh, thank you. Yeah.
Hunter, who's your partner? Right? Okay. Do we not have an odd number? No, we're going to partners. Here we go.
There's,
Congratulations,
Yeah,
Barrett,
well,
you have a partner.
Okay, let's be partners. Although I feel like I'm gonna make it because of our.
Oh, wow, yeah.
I'll try it.
That's why I gave you the problem for this time.
Okay. So I'm gonna need you to help me find a sequence of the K.
Yeah. Tell me what I need to know.
So, how about you tell me exactly?
All right, so as you're working, don't show each other your cards.
Starting with the first bullet point. What's the first bullet point?
Don't show each other your cards. Complete the problem. When you get done, bring it up to me. I will check it, and then I will give you the next set of cards, and you'll switch roles.
Okay.
So if you have a problem card this time, you get to give the data next time, and vice versa. Go.
It's gonna be, K and monthly. K for the seals and monthly.
If you're watching the video, I'm going to need you to look at the slides that I've attached and kind of look at the problem cards and the data cards and the correct answers that are in there, because I'm not going to have time to go through all of it together.
We are moving on. Okay, here are the correct answers. Most of you have them. All looks good there. Okay, now you're gonna make your own visual representations of the sequence below. Okay, so you can make a graph, you can make a table, you can make an equation, you can make all of those things. This is on that little half sheet that you're gonna put in your notebook, okay? But they have this sequence here, 2, 8, 32, 128. You're gonna take the next 3 minutes. Okay, so for 3 minutes, and you're gonna make your own visual representation of that sequence. Okay, if you finish with one kind of representation, like if you made a table, then go ahead and also make a graph or also make an equation. Try to get all of the forms in. All right, now that you've had 3 minutes, go ahead and turn and talk with your neighbor about what you did and what they did. See if you did the same thing.
I did all three. I did the working background, and then I did working table.
Well, so I don't know.
I think there's others.
I don't know if that's right or not. That was my best guess on how to.
I did
Regulation. I don't know.
It's worth it.
Medians, I know about this.
In my next dollars.
Most times that, apparently I'm first, like, I don't even know.
Okay, oh, that, I didn't know, yes.
Oh,
Wait, you have to read.
okay. I wrote that. So I wasn't total.
Still talking about the previous steps.
What was the reason for us? So it's always been much.
If it was in plus one, that would be the next step. You know, the next step is we have to. Right.
No, they're like a set over, so 60, I think.
All right, so up here I've got a table, I've got a recursive definition, and I've got a graph. What kind of sequence is this? Arithmetic, geometric, or neither? Geometric, why? It's geometric because it's multiplying by 4 every time. Hey, did anybody come up with an equation other than that? The rate we didn't have to talk about yet. 4n. 4n. I just missed it.
That's nice.
Because I didn't know.
I like that.
If you want it, that's fine. It didn't give you a letter, you can use whatever letter you want. Okay, if you did come up with an equation, it would be 2 times 4, and minus 1. So you're right. All right. So glue that in on page 148, and then page 149 is our last set of notes that says the nth term. And it is the last set of notes that you will put in this book.
Let's go.
It's gonna be after.
There you go.
This review is just for this unit, and then the review and final grade. Okay?
Look right there.
I don't think it's difficult, but I can't teach that one because I don't have any years.
Yeah, that's true, but like, I'm like, that lessons is super hard.
It was your, I like to take a picture of your, I got it.
My table come down?
Yeah.
Maybe like the one that was at the beginning of the slide. I mean, I'll put this on the thing, so it'll be on there. You'll have access to it.
Oh.
All right, so on your notes, which one of these 4 does not belong
Bro, that's a meeting.
on your notes, and explain why. Be prepared to defend your answer.
Can I get the calculator? Sure. Okay, I'm gonna use my cell phone.
Okay, talk to your neighbor about which one you said doesn't belong and why.
Okay, so figure out A and B, C, 17, and then C, 320. Not bad. Almost everybody. What's kind of
Yeah, 2 is 7. Plus 2 is 9. C is 5. Plus 2 is 15. Plus 2 is 7. Same thing with 2 driver and 6. C 30 is 6 times. And the distance of the 5 is 6. And then
Alright, who said that A doesn't belong?
And multiple not belong?
Huh?
And multiple not belong? Sure. Okay, so I'm gonna say C and D then.
C and D don't belong?
Yep.
A does.
A and B do belong.
A and B both belong, okay? Is there anything special about part A that none of the other ones have?
in what context does this belong?
It's arithmetic.
Well, okay, I'm gonna put it,
Arithmetic.
It's arithmetic?
Yeah.
oh,
Well,
sure.
Bro, who made that? I thought you was supposed to, man.
What?
No, words.
Yeah, so that, part A, they're saying they start with 5 and they add 2 every time, so it would be arithmetic. Okay, what did you get when you typed that in? Anybody?
17.
17?
17 you get for A and B, and then 320 you get for C and D.
That's a movie, man.
Spoiler alert.
Okay, so look at part A and part B. Why do they equal the same thing?
Because there's, yeah.
There's 6 2's, right? Isn't 2 plus 2 plus 2 6 times the same thing as 6 times 2?
Yes. It's all true. It's all, wait, hold on. You wouldn't believe it.
Crazy, right? What'd you get when you typed C in the calculator?
320.
And Z?
320.
Do those mean the same thing?
Grace.
Does 2 times itself 6 times equal the same thing as 2 to the 6th power?
Yes. None of them.
Okay, all of them don't belong for a different reason. Okay, part A is the only one that has repeated addition. Part B is the only one with addition and multiplication. Part C is the only one with an exponent. Part D is the only one that has multiplication a bunch of times. So there's that.
Okay, is this how they all are? Like, they're all right and they're all wrong. I mean, then maybe we should focus on something else.
No comment. All right, so we're back to Claire with her 8x10 piece of paper that she's gonna cut a bunch of times. Remember that from the other day? Okay, so Claire takes that piece of paper and she cuts it in half, then she cuts it in half again and again and again. So instead of writing a recursive definition, Claire writes this equation, C of n equals 80 times 1/2 to the n power. power, where C is the area in square inches of the paper after n cuts. Explain where the different terms in her expression, which should the equation come from. Okay, so she has 80 times 1/2 to the n power. What does 80 stand for, or where did that come from? Did you just pull 80 out of thin air?
Yes.
It's the area with 0 cuts. So 80 is her original area. Where did she get a 1/2?
It goes to almost one side, almost half, or is that?
It's 1/2 for each step, right? Does anybody remember what that's called when you multiply by the same number every time? It's geometric, but what is the, like, this actually called?
Growth factor.
There we go.
Oh,
growth
that's,
factor.
No, let's get there.
I think it's right.
Okay, what is n? N is the number of cuts. Okay, notice that this table starts at 0, even though a lot of the tables we've seen so far started at 1, right? Okay, just something to keep in mind. And then part B says approximately what is the area of the paper after 10 cuts? How would you figure that out? You just divide cut a paper 10 times?
Yeah.
Sure.
10 times.
But you not just like use her equation?
Yeah.
No,
Or we could get a paper and cut it in half.
That's not.
This where it is 0 papers?
I don't know. Okay,
See, it's not now.
let's plug in 10, C of 10
Wait.
equals 80. She gave us an equation, so let's use it. It's 1/2 to the 10th power.
I don't really trust Claire, though.
Do we?
Yes. I need to
Spell the kind of right.
Who cuts this much paper?
No one.
Alright.
I don't.
Oh.
Okay, you get
Yeah,
a
that's what you
decimal.
meant.
You get
I
a
did.
decimal. Somebody tell me what it is.
1078.
1078. What does that represent?
The area represents
The area of the paper after
10 cuts.
10 cuts. So if we're talking about area, wouldn't that be square inches? Okay, in case anybody cares as a fraction, it's 5/64.
Oh,
It's 9/64 of a square inch.
There.
So do you really want me to cut it?
Yes.
yes, can I try?
Okay, I'll let you do that later.
Bruh.
Okay, important part here is that you realize, did I have to figure out step 9 to get step 10?
Yes.
Bruh.
I didn't. Okay, all the recursive definitions we've done, you had to know every single step up until the one you were talking about, right? So to figure out step 20, you had to know step 19. With her equation that we have right here, I didn't need to know that at all. I didn't have to know step 9. I just got to immediately figure out step 10. And this is hard and helpful. Saves you some time.
Yeah.
All right. So Karen, let's see, Karen? Karen
wrong.
takes a piece of paper that's 8 by 10
Alright.
and cuts away 1 inch of the width. All right, so. I've stared at this one for a long time. If he takes the piece of paper and he cuts off 1 inch of the width. Okay, so he originally started off with 8 by 10. Okay, and then he's gonna cut off 1 inch of the width, so we have an 8 by 9, thank you. Okay, so if he takes off 1, it's 8 times 9, which is 72. Or he took 80 and subtracted 8 one time. So if he cuts off 1 inch of the width, it's going to be 1 times 10. So 80 and then 72 takes away 8 again, cuts off another, 64. Okay, fill in the rest of that table. Did you have it on your paper, right? Okay. Okay, so fill in the rest of that table.
Wait, we just put the answer, we didn't want like the 80 minus 8 minus.
Either one.
Did you get that filled in, Miles?
Yes. No way. Hey, you can look.
Wait, is that what?
Yes. No way. Yes.
I figured it out. At least figured it out. It's just like, I couldn't figure it out. I mean, no, that's just odd. It's wrong.
All right, so how much area is left after 3 cuts? After 4 cuts?
48.
After 5 cuts?
40.
All right, so let's look at it how they have it written out. Okay, so 80 minus 8 minus 8 is 80 minus 8 times 2, right? For step 3, it would be 80 minus 8 times 3. For step 4, 80 minus 8 times 4. 80 minus 8 times 5. You with me?
So you're taking something kind of simple and making it complicated, as per usual.
Okay, so underneath on yours, here it says that the area after 6 cuts in square inches is 80 minus 8 times 6. Okay, where did those numbers come from? Where did 80 come from? The original area. Where did the 8 come from?
The amount of the
Yeah, the amount that's decreased every time. And then where did the 6 come from?
just step. So,
Step number or your 6 cuts, right? Okay, so if I'm writing a definition for K of n that's not recursive. So for any number of cuts, K of n, how do I figure out how much area is left?
80 minus 8.
80 minus 810. Because I'm starting with my original area of 80, taking off 8 each time, for however many cuts I make. You with me? All right. One other thing I want to talk about. Am I going to be able to continue this sequence forever and ever and ever?
No.
Why not?
Because you'll wait, maybe.
Right on 0 paper.
You'll hit 0.
I'll hit 0 at some point. When do I hit 0?
When you cut the paper.
Oh, just keep getting it.
Or like 15 cuts.
Like 15?
That's okay.
Type it in and see.
How do you know that?
80 minus 8 times 15.
Oh, crap. I was.
Isn't it possible?
It'll be real small. Negative 42.
Okay, am I going to have an area of negative 40?
No.
Probably not. Okay, Robert, why did you say 10?
Because 8 times 10 is 80 and 80 minus 80 is.
Oh,
So can I make it 10 cuts?
GG's.
Well, you could, but it would be 0.
Okay, so I can only have n values between 0 and 9. Because when you go make that 10th cut, there's nothing there. All right, so that number 3 question is at the top on the right of this paper, and it says, which one is going to be larger, K of 6 or C of 6? Okay, so using your equations, you have 2 equations, this one that we just created, right? And the one that we had originally for Claire. We want to know which one is larger, K of 6 or C of 6?
So use your calculator, do the math. Which one is larger, K of 6 or C of 6?
I got it. Okay, what do we get for C of 6? What? 1.25? And then for K of 6, so which one was larger?
The 32 one.
K of 6. Okay, so now let's have this thought process. What kind of sequence was C of N? Arithmetic, geometric, or neither?
Geometric.
Why?
Because the time focus on the dimension.
It's geometric because it's multiplied by 1/2 every time. So won't that one decrease a whole lot faster than this one? Because what kind of sequence is this? Not geometric, we're not multiplying, what are we doing? Subtracting. Whenever you subtract the same number every time, that's arithmetic. Okay, whenever it looks like an equation like this, it's what's called an explicit definition. Explicit definition defines the nth term of a sequence using just the position of the term. And you want to use an explicit definition if you're trying to find a term way down the line. So like if you're trying to find the 20th term, you don't really want to have to find all 19 until you get to 20, right? You want to be able to just find the 20th one. That's what's so nice about an explicit definition. This is the kind of definition you would want to use on the ACT when these kind of problems show up. The explicit version, the equation version rather than the recursive where you have to know each term. Okay, this one, these triangles should look familiar because they were on homework 53. It's the same triangles. We were created by starting with an equilateral triangle, breaking that into 4 congruent triangles, and then removing the middle one. Starting from a single black equilateral triangle, this is what it looks like. So part A says let S be the number of black triangles in step N, and define that recursively. So recursive definitions have how many parts? 3 parts. Okay. So I need to know my first term, S of 1. How many triangles do I have in that first term? 1. Just 1. In the first one. Okay, and then what's happening between each one? How many black triangles do I have here? 3. So here I have 1, here I have 3. How many black triangles do I have here? And then 27, right? So what's the pattern? It's multiplying by 3. So for any term S of n, I'm gonna multiply 3 times the number of black triangles in the one before it. S of n minus 1. For any step greater than or equal to 2. Part B, Andre and Lynn are asked to write an equation for S that isn't recursive. Andre writes S of n equals 3 to the nth power for n greater than or equal to 0, while Lynn writes S of n equals 3 to the n minus 1 for n greater than or equal to 1. Whose equation do you think is correct? Explain or show your reasoning. Okay, so I'm going to give you like 3 minutes to do some math on your paper and figure out who do you think is correct. Ready, set, go.
I felt hungry for this.
Okay, so do we think Andre is correct or Lynn is correct?
Andre's correct. Andre short.
Andre both.
You.
All right. Who said Andre? All right. Why do you think Andre is correct?
Yeah.
When, what's your business?
Andres didn't work.
I don't know, I just,
Okay. Well, let's look at Andres. Okay. S of n equals 3 to the nth power
I do that.
when n is greater than or equal to 0. Okay. So let's just try it. If we plug in 0, 3 to the 0 power is what? 1. 3 to the 0 power is 1. Does my first term have 1 black triangle? Yes. Okay. Now if I plug in 1, 3 to the first power is 3. Does the next term have 3? Yes. If I plug in 4, what's 3 to the 4th power? Nope, I lied. If this is 0, then 0, 1, 2, 3. What's 3 to the 3rd power? 27. Does that work? Yep. So Andres does work. His works just fine. Okay, but a lot of you said that Lynn was correct. Don't be erasing stuff yet, people. Okay, Lynn wrote that S of n equals 3 to the n minus 1 when n is greater than or equal to 1. Okay, so this is saying we have step 1. Okay, so for step 1, it should be 1. What's 1 minus 1? 0. What's anything to the 0 power? 1, so does it work for step 1?
Yes.
What about step 2?
Um,
2 minus 1
Oh,
is 1,
yeah.
and 3, the first power is
yes.
3.
So it does.
Right, and for step 3.
So they both work,
Yes.
okay?
I'll be strict questions on this one. What's up?
They both work because they give you the domain. You have to look at what the domain is. If it's greater than or equal to 0, that means your first step is step 0. Like on that table we were talking about. Remember that table started at 0? Yes, no? Yes, all right. So if your table starts at 0, then your first step is step 0. If it starts at 1, then your first step is step 1. They're both correct. They both give you the correct sequence, okay?
How do you find the domain?
I don't like all these trick questions. I'm thinking,
How do you find the domain?
Yeah.
Okay, so for this one, based on what you wrote, you either start with 0, 0 or 1. You're always going with that, okay? So for here, 0 works just fine, so you can plug in 0. For this one, if I plug in 0, I get 1/3, and that doesn't work. So you just have to plug it in and see, but you're always only going to check 0 and 1. Okay.
Then why is it 2 on the other?
Why is it 2 on the other ones?
Yeah.
Because if it's recursive, you have to give the first step, and then give a rule for every step after that. So on all the other ones, you start at 2, because you give the first step.
Okay, thank you.
All right, one other thing I want to tell you is I will not be in here with you guys on Tuesday next week
On study day?
on study day, but Miss Perkins will be here.
Oh.